Hi, everybody. I'm going to go over graphing logarithmic functions today. So we're going to first start with exponentials and see how logs are a little bit different. So let's say we have y equals 10 to the x. So this is just a basic exponential function. So you know how to do that. We're just going to make a little table here. So I'm going to plug in -1, 0, and 1. When I do that, 10 to the -1, remember it flips it, it's 1/10. Anything to the 0 power is 1, and 10 to the 1 is 10. So let's graph that. We know that it has an asymptote, has a horizontal asymptote of y equals 0. I'm going to graph -1, 1/10, somewhere like that. 0, 1, and then 1, 10, way up here somewhere. So my graph looks something like that. That's my exponential. And you also know for this that the domain is basically all real numbers, so -infinity to infinity. And the range is from the asymptote up. So starting at 0, every value above that works, but 0 is not included because it's an asymptote. So 0 to infinity. Okay, so those are the basics. Now, to do a log function, let me rewrite it here. You already did a little bit the other day in the notes on this. So this is logarithmic form, and this is exponential form, right? So the main idea with these is that the x and y are flipped. The reason for that is because log functions and exponential functions are basically a reflection about the line y equals x. So if it's a reflection about the line y equals x, it basically means that the x and y are flipped. So let's write that down too. It's a reflection about y equals x. That's what inverses are always are. And the x's and because the x's and y's are flipped, the domain and the range are also flipped. Okay, so that means that y equals 10 to the x and y equals log base 10 of x are inverses when all these things are true. Okay, so if that's the case, then let's go ahead and make our table for the log function. So because they're inverses of each other, we're just going to flip it. So this becomes 1/10, 1, and 10, and this becomes -1, 0, and 1. Okay, so when we graph this, instead of, so the asymptotes are also flipped. So instead of a horizontal, it has a vertical. Did I write that? I don't think I wrote that. But the asymptotes are also flipped or switched. Flipped, switched, whatever, same difference. So this has a vertical asymptote of x equals 0. So instead of y equals 0, it's x equals 0. So we have x 1/10 -1, 1, 0, and then 10, 1, so somewhere way out here. So my graph is not that beautiful, but you get the idea. There it is, and it looks like a reflection, so we did that right. So along with the vertical asymptote, for this one, we have the domain, which this time is x is bigger than 0, right? So 0 is not included, so 0 to infinity. Notice it's the same thing as the range, okay? Which means the range, all the y values work. So -infinity to infinity, okay? Let's fill out this stuff. So to find the inverse, you switch the x and the y. I'm referring to this here, okay? And then when we rewrite it in log form, log base 10 of x equals y. Okay, that's how you go back and forth. And then we can plug these points in, make a table. So log 10 you can do on your calculator. So if we plug in, like, if we plug in stuff for y here, we can get an x, or we can plug in stuff for x and then just do log of that number. That works as well. I would probably start by just plugging stuff into here. It's just easier. So 10 to the negative 1 is 1/10. 10 to the 0 is 1. 10 to the 1 is 10. 10 squared is 100. Okay. This has just a little extra stuff. So the translating is exactly the same as what it used to be for all the different functions. So I'm just going to write the basic rules again. Hopefully you guys remember all these are the same for everything. So if I have a log function plus a number, that means you go up whatever that number is. If it's minus a number, it goes down. So that's all the same. And then if I have the adding and subtracting inside the parentheses, this one goes to the left, whatever that number is. Remember, it's the opposite when it's inside the parentheses. So this goes to the right, whatever that number is. And if you have a negative, it's a reflection about the x. Okay, so tips. You want to use the transformations or the translations to get the asymptotes. And then use tables. I'm going to show you how to do that right now. So remember when we did a bunch of tables for exponentials and we told you, this is kind of long, but when you do logs, it's going to pay off. Well, here it is. It's going to pay off. Hopefully you agree, but I think so. All right. The way we used to teach this, we had to put it in exponential form and do all kinds of stuff, and students always used to mess up on that. So this time, we are going to use tables. That's what we did last year, and it worked really well. So the idea here is you want to start with the parent function, but you want this to be the exponential. And then we're going to flip all the points to get the logarithmic one, and then we're going to apply the translations. So you're going to do the exponential parent, then you're going to flip to get the log, and then you're going to apply any translations. Meaning left, right, up, down. What do? Do you add to the x coordinate or the y coordinate, that kind of stuff? Okay. So because this has a 2 here, I know my parent function is going to be y equals 2 to the x. If that was a 3, it'd be 3 to the x. If it was 5, it'd be a 5 to the x. That's the basic idea. Don't overthink it. That's all you have to do for that. Okay. And then this is just like what we had a test on. So 2 to the negative 1 is a half, 2 to the 0 is 1, and 2 to the 1 is 2. Okay, so that's the parent function that's exponential. So now we want to do the log function. But this is the parent one because there's no translations yet. Okay, so the parent log function, which is y equals log base 2 of x. So remember, because they're inverses, you just take these coordinates and flip, flip, flip. So 1/2 negative 1, 1, 0, 2, 1. There it is. Now, because there's no translations, great. We don't have to do anything else to these tables. So remember, with logs, you have vertical asymptotes. Okay? Whoops, you can't see that. Vertical asymptotes. So because it doesn't move right or left, the asymptote is at 0. So x equals 0. I'm zoomed in a little too much. Let's fix that. Okay, so x equals 0. And then I'm going to graph this. So half, -1, 1, 0, and then 2, 1. Right? The domain is x is bigger than 0, so 0 to infinity, and the range is -infinity to infinity. Perfect. So this is what we're starting with. Easy peasy. Okay, now let's do some shifting ones. So because this has a base 2, I know my parent exponential is going to be y equals 2 to the x. So it's the same table that we just used. Pretty much all of these on this page are going to have the same parent exponential, just so you don't have to do a bunch of extra work. Okay. So now we're going to do the parent log function. So I'm going to take these coordinates and I'm going to flip, flip, flip. So 1/2, -1, 1, 0, 2, 1. And now I'm going to apply for the final log. So let's look at what's happening here. I have a -2 inside. That means it goes to the right. So you're going to +2 to the x coordinate. Okay, you're going to +2 to the x coordinate. So +2, +2, +2. This is exactly what we did for the exponentials. Okay. Oh, I forgot to write the equation. This is the final one here. Okay. So 2.5. 1 + 2 is 3. 2 + 2 is 4. This stays the same. Now, because it goes to the right, anytime it moves right or left, it affects the vertical asymptote. So that was one of the tips that apply to the asymptote. So we need to move it 4 to the right. So 1, 2, 3, 4. So instead of 0, my asymptote, not 4 to the right, 2 to the right. It'd be nice if I could count. I don't know where I got 4 from. Anyway, it's going to look kind of messy, but that's okay. Oh boy. This is why we always tell you to do your work in pencil. Okay, so x equals 2 because it goes to the right too, so the asymptote moves to the right. And now I'm going to graph my points. So 1, 2.5, -1, and then 1, 2, 3, 0, and then 4, 1, 2, 3, 4, 1. There's our graph. The domain is 2 to infinity because notice all the x values start here at the asymptote, and the range is -infinity to infinity. All right, so that was a right-left one. Now I'm going to do an up-down one. Then I'm going to do a combo one, which is number 4. And then I'll show you what you would do for the reflection, but I'm not going to do all of those. It's just too long. We'll publish the notes key later so that you can see those and you can try those yourselves. I don't want this video to be like 5 hours. Just kidding. It won't be that long. Okay, same thing. The parent function, because that has a base 2, is y equals 2 to the x. I feel like we should write these on all of these while we're at it. Might as well. And remember, the way you know what to do is look and see what's the base there. Because it's a 2, it's 2 to the x. If it was a 3, it'd be 3 to the x. So hopefully you understand that pattern. Oh, what the heck? Let's do this one too. Anytime you want to pause the video and try something yourself, I think that's a really great idea. I know some of you probably just plow through these, but it is kind of nice to try it on your own. Okay, so these are all just like the standard one we've been using, just so it's a little bit less complicated here. Okay, so after we get the parent exponential, then we need the parent log. This is where we take the points and flip, flip, flip. Trust me, if you don't do these tables, you try to do it with inverses and stuff, it's so easy to make mistakes. And students used to do it all the time. So trust me, I know this looks like a lot of work. And some of you just want to fight it because you want to show as little work as possible, but it is worth it. Usually when students follow our recommendations on making these tables, they ace all of these questions. So obviously, it's a good idea. Okay, so now I'm going to flip these. So I get 1/2, -1, 1, 0, 2, 1, blah, blah, blah. These are all the same. Okay, perfect. So now we're going to apply the final log with all the translations. I always make these videos at night after a very long day. So if I make stupid mistakes like thinking it was 4 instead of 2, just know it's not fresh in the morning for me when I'm making these. All right. Final log. Let's look at this. So this one goes up 4. So anytime you go up or down, you are affecting the y coordinate. So when it's up, we're going to add 4 to the y coordinates. Okay, so +4, +4, +4. I'm not going to write that final equation. I'm going to pull the lazy card. -1 + 4 is 3. 0 + 4 is 4, and 4 + 1 is 5. Now, because it doesn't move right or left, the asymptote is not changed. The asymptote for logs only moves if the function moves right or left because it's a vertical. So 1/2 3, 1, 2, 3, 1, 4, 1, 2, 3, 4, and 2, 5. 1, 2, 3, 4, 5. So it's the same basic shape, it just moves up. So this doesn't change. The domain is still 0 to infinity. And the range for all of these is going to be that. Okay, so now let's look at our shifting for number 4. So this one goes down 3. So I'm going to -3 from the y coordinates. And then inside here, because it's a +2, it means it goes left 2, right? And since it's left 2, we're going to -2 from those. So for my final, 1/2 - 2 is -1.5. 1 - 2 is a -1, and 2 - 2 is 0. -1 - 3 is a -4. This is a -3, and this is a -2. Now this moves to the left 2. Because it moves to the left 2, the asymptote also moves to the left. So x equals -2. You always want to draw the asymptote first. Okay? And then we do our points. So -1.5, -4, 1, 2, 3, 4. -1, -3, 1, 2, 3, and 0, -2. Right? The domain is -2 to infinity, and the range is -infinity to infinity. Now on this one, there's no shifting left, right, up, down, or anything, but there is a reflection, right? So because it's a reflection, you're going to multiply the y coordinates by -1. So times, remember you already did these before, the multiplying. So my final on this one is the same. Is a +1, a 0, and a -1. And because it doesn't move right, left, or anything like that, the asymptote is still x equals 0. So 1/2, 1, 0, and 2, -1. So notice it's just reflected about the x. The domain is still 0 to infinity, and the range is -infinity to infinity. All right, this one you can do on your own. You're going to multiply the y coordinates by negative, and this inside here, because it goes to the left 1, you're going to minus 1 from the x coordinates. All right. I'm going to make a different video for the next side so that each of these isn't too long.